Good morning, students. Let's do our lecture on carrier sense multiple access. In the other last class, we have done carrier sense multiple access on persistent methods. We have seen different persistent methods. The three different persistent methods are one persistence, non-persistence, and p-persistence. In one persistence, we see that the channel is continuously sensed, and then whenever the channel is free, the data frame is being sent. Whereas in non-persistence, we see that the sensation is done on the random wait time. Whereas in P probability, we see that the sensation is done on equal interval of time. And then today we'll be doing about CSMA protocols. That is CSMA collision detection. In CSMA protocol, we have seen that the principles of CSMA is to sense the channel before you transmit the frame or listen before you talk. Whenever we hear about the carrier busy, you say that the transmission is taking place in the channel. Carrier is idle. We say that no transmission is taking place in the channel. Now, collision detection is one of the method wherein you see that if two stations senses the channel to be idle and begin to transmit simultaneously, it's an example of one route or one way, wherein you see that a narrow path will be and two cars, or you can have any four-wheeler is trying to come. You see that when they reach to one particular position or one particular point, you see that both of the two-wheelers, four-wheelers cannot move further. That means they stop at that particular point where they collide, when they meet each other. That is what is called as collision detection, wherein you see that either of the two four-wheelers cannot move further. That is one of the good example of carrier sense multiple access wherein you see the collision detection will take place. So here we see that they both will detect the collision immediately. And then we see that rather than finish transmitting the frames, which are retreated, garbled anyway, they should abruptly stop transmitting as soon as a collision is detected. You see that instead of wasting the time and trying to transmit, now let's take the example of the narrow path wherein you see that the four-wheelers meet each other. So you see that they both cannot move further, and then they should not waste any of the further time. So here what they have to do is they have to terminate that particular point and just resolve it. That is what is called as terminating damaged frames saves the time and also bandwidth. So here we see that collision detection is mainly used in LANs in MAC sublayer. Now let's look at this particular diagram. We have four stations, and these four stations are trying to transmit a frame. Now we see that at T1, you have 8 station trying to transmit this frame. And then at the T2, you see that C station is trying to transmit a frame, because the C station will assume that the channel, whatever is there, is completely idle. Now, before the A frame reaches to the edge of the C, you see that the frame of C will hit the first bit of the A. So here we see that the collision between the A and C will take place, and then you see that the transmission is being aborted. By the T3, you see that collision has taken place. A collision detection and abortion is found at T4. So this is what is called as collision of first bit in collision detection CSMA. Now let's look at the flow chart. We have K, which is nothing but the number of attempts, and maximum propagation time is given as T tot. Here you can see T tot. R is the random number. TFR is an average transmission time for any frame. Backup time is given as TB. Now let's see what happens in the flowchart. Station as a frame to send. So we see that it can apply any of the three persistent methods. One persistent, non-persistent, p-persistent. And then we see that the transmission can take place or collision can detect. Once the collision is detected, you say that the collision has been detected and then it comes out. If it is no, that means the transmission has taken place. Here also you see that if the transmission detection collision is detected, no, then you see that transmission of a frame has taken place and it has been received by the receiver side. Now let's further move on. Now, if the collision detection has taken place, what is the reason? It can be this because of the jamming signal, or it can be the collision of another frame. That is also called as a jamming signal. So here we see that k is equal to k plus 1. Then immediately k is greater than k of maximum, and then it comes aborting. If k is greater than k of maximum, then it is no. Choose a random number r between 0 to 2 to the power of k minus 1. Then we can calculate the weight back of time, which is nothing but r into t dot or r into tfr, which is nothing but the average transmission time for the frame. Now let's see what happens. A user wishes to transmit, listens to the channel if it is free. If it is idle, it transmits the frame. If the channel is busy, it keeps listening until the channel is free, then transmits immediately. This is nothing but one persistent method. During the transmission, it listens to detect the collision. During the transmission, we see that it always senses the channel. The reason is to avoid or to check whether there is any collision or if the channel is again busy. So here you see if collision is detected, it stops transmitting immediately and waits a random period of time and goes back to step 1. So here a random period of time is nothing but non-persistent method. Now, different states of CSMA CD, that is you have transmission period, contention period and idle period. Let T be the end to end the propagation time. Worst case is to detect the collision is 2t, 2 dot. 2 dot. Frame should be long enough to allow collision detection prior to the end of the transmission. Otherwise, collision detection degrades to CSMA. Binary potential backoff is used when repeatedly the channel faces collisions. Now let's look at this one of the example. A is a channel station and it is trying to send a particular packet at T0. By the time it reaches to the T to the power of E epsilon, we see that it doesn't reach B station, that is the receiver side. Now assume that B started to send one particular frame to the A, thinking that channel is free. Now collision will take place at the time T. Now here you see that there is the noise burst gets back to A at 2T. That is nothing but you see that there is a written, that is the frame which has been sent from A to B is being collided. So you see that there is a noise burst at A. Now we have a frame. This is about collision detection and different states. You have transmission period, contention period and idle period. Just now we have seen here the different states of CSMA CD, transmission period, contention period and idle period. Now let's see what is the transmission period. Transmission period is the time taken for the frame to pass through the channel. Contention period is the one wherein you see that immediately after transmission of one particular frame, you have contention period. So you see that it is a contention period which is here. Now, idle period is the one wherein you see that the channel is not busy, it is completely idle. That means there is no frame which is passing through the channel. See, immediately after this particular frame, you also have the contention period. So this particular contention period is also given as contention slots. That means you can have different equal interval time slots given for the contention. So that is what is called as contention slots. So immediately after each frame which is been sent, we see that contention period is followed immediately of the transmission period. Idle period is the one wherein we see that whenever there is a channel and there is no frame being sent. Next, we have efficiency which is being given by 1 plus 6.44 into D. Alpha is being calculated by T of tot by T of T. If the distance increases, the efficiency of CSMA decreases. As the distance increases, the efficiency decreases because we are not sure whether the frame which is sent in the channel may be received to the receiver side. CSMA is not suitable for long distance network WAN, wide area network, but it is only suited for local area network. The length of the packet is bigger, the efficiency increases. But the maximum length is limited to 1500 bytes. The transmission period is greater than round trip time of 1 bit. And it is also greater than or equal to 2 into propagation time. Collision and abortion in CSMA CD. Now the same thing, whatever I told you in the earlier one, this is the same thing what it is. So coming to CSMA, collision avoidance, this particular method is a network multiple access method in which the carrier senses sense, but the node attempts to avoid collision by beginning transmission only after the channel is sensed to be idle. It is practically important for wireless networks where the collision detection for alternative CSMA-CA is not possible due to wireless transmitter desensing the receivers during packet transmission. Collision detection is unreliable due to hidden node problem and exposed terminal problem. So with this, we can stop here. So here, this is the end of this particular lecture.